we have a single element plus a compound, which is how we will know this is a single replacement reaction. Anytime you identify a single replacement reaction, you're going to need to use an activity series to verify will the reaction occur. We're going to compare aluminum to lead, and we have aluminum here and lead down here. So aluminum, because it's higher up on the list, will get a smile, and lead is going to get a frown. So we're going to put a smile on aluminum and a frown on lead, and we're going to give the fluoride an arbitrary little circle. Now, when you look at the compound, it has to be a happy couple, but you see the frowny face there? That means that these two elements are going to switch spots so we can get a happy couple. So the lead is going to go in place of the aluminum. That's my frowny face. And then the aluminum is going to come in place of the lead, and then we're going to put the fluoride. Do not carry over subscripts. This is my happy face. This is my little ring. And now we have a happy couple. Anytime you have an element that's a single element as a product, you have to verify, is it one of the 7 diatomics? It is not one of these 7 diatomics, so it does not get a subscript of a 2. When you form a compound between two elements, you have to balance their charges. So aluminum has a positive 3 charge, fluoride has a negative 1. So if I put positive 3 versus negative 1, for these to be balanced, we're going to need 3 fluorides because 3 times 1 is negative 3, which will balance with this positive 3 here. Now that I have found my subscripts, I can balance the coefficients. We have 1 aluminum, 1 lead, 2 fluorides, 3 fluorides. So a common factor of 2 and 3 is 6. So 2 times 3 equals 6, and 3 times 2 equals 6. So I have 6 fluorides on both sides. This has modified 2 things. First of all, we now have 3 leads on the left, so I need a 3 here. We now have 2 aluminums on the right, so I'm going to need a 2 here. Final answer is 2 aluminums react with 3 lead fluorides to yield 3 leads and 2 aluminum fluorides.